All right. So it's time, like in a Swiss clock, so we start really on time today. I really warm welcome you to our presentation, the Red Hat Ansible Automation Platform as a service based on Red Hat OpenShift. Today, my colleague Silva and I will present you how we at SIX create quite a cool solution for our internal employee to bootstrap Ansible automation platforms on demand. So to give you a quick idea what we are going through today, that's actually an agenda for today. So we introduce ourselves as well as SIX. So maybe some of you guys already heard about SIX, maybe some of you not. We will show you the basic architecture of a Kubernetes operator as well as of AAP2. Move forward to the operator cooperation. That means how we customize the AAP2 to fit in our environment. Followed by execution environment. That's something new coming in AAP2 when, coming from an older version like Ansible Tower, something like that. And of course, when you have a good product, you also want to migrate your customers. So that would be also a point there, as well as then real customer use cases. With that said, I would like to pass over to Silva to introduce himself.
Thank you, Philippe. My name is Sylvain Chen. So I'm a principal consultant at Red Hat. I joined Red Hat in 2017. I've been working with containers and Ansible for quite some years. And today I'm thrilled to be with Philippe today to talk about AAP on OpenShift. Now I would like to hand over to Philippe who will continue the presentation.
Thank you much, Silva. So my name is Philippe Hutter. I work as a Kubernetes engineer at SIX in Switzerland, working with container quite a while now. And since 2020, I also started to work with Ansible. Before I had quite some work with Puppet, but as you may know, it's quite hard to let someone first love go. So I was still really into Puppet, but increasingly use Ansible as well. With that said, we want to move forward to introduce SIX. So what is SIX actually? And maybe some of you know that already, maybe some of you not. And I would like to start with a quick question to you. So everyone who used Swiss francs, the currency of Switzerland, before, please raise your hand. All right, some of you. And have you know that you actually used most likely a service of us? Quite certain that you used it. So what are we doing? And SIX operates the Spanish as well as Swiss stock exchange. But we are not only operating stock exchanges like the traditional ones, we are also trying to build innovation, to build something new. Therefore, we also had the Swiss Digital Exchange. It's called SDX. It's a new product we invented like 2 years ago, which is an exchange based on distributed ledger technology. So quite some cool new things. But it's not only exchanges. We also have like the security services, like the whole post-training, this whole security value chain, so-called. Besides that, we have as a global partner, we have banks, financial institutions who use financial information. Like, for example, the SMI, so the Swiss Market Index, things like that. Also, when you have all the stocks, all the information, all the events for regulatory purpose, goes then over our systems. And last but not least, and now it comes to the point where most of you used us, even if you haven't known that you used us, is banking services. So we operate or we deliver the financial backbone for the Swiss financial industry. For example, ATM, cash, but also various payment and billing systems in Switzerland. But it looks a bit broken on this beamer, but it should represent actually the word behind it. Not sure why it doesn't work. But we are not only located in Switzerland and in Spain, where we operate actually the stock exchanges, but we are around the globe. For example, in Singapore, as well as Japan and US, like where all the financial centers are located. Saying that, as you heard now, we are really building financial services, and we always try to fulfill efficiency, reliability, and security. It's really these three main pillars the customers, so the banks, and also you as an end user, I would call it, requests from us. So until now, it sounds really a business presentation, so I would like to move to the technical one. Whenever we build a system, and in this case, this service like Ansible Automation Platform as a service, we also depend on these three main pillars. In this case, just to give you a bit more of a history, we started quite early deploying Ansible Tower, it's the old version of AAP, on OpenShift 3 back in the days. It was never officially supported by Red Hat, but it gave us the ability to have already back in the days a product, a service, which provides you the 24/7 support to whenever you want to have an instance deployed by yourself. Everything is infrastructure as code, since everything is in OpenShift, and you have the ability of consistent automation and lifecycle. Now, Red Hat with AAP2 invented the same thing as we had. Therefore, we also moved to it. I mean, why you shouldn't use the things Red Hat provides you. Therefore, with OpenShift 4, we switched to AAP. All this basic functionality we had before are also available in AAP2. But there are for sure more features coming. And I would like now to hand over to Silva so that he can present all the new features.
Thank you, Philippe. So let's talk about Ansible Automation Platform 2, but more focused on OpenShift. And what's the difference between the infrastructure on OpenShift and the other kinds, like if it's deployed on VMs. So first, let's talk about the product itself. So what it brings on the new version is the deep coupling of the control and execution plane. So that means you have really the different pods that are now separated. So that means you can really scale your execution plane as well as your control plane in an independent way. You have also the execution plane really resilient to latency and interruptions. And for the OpenShift case, you really can rely on the cluster capacity that is completely dynamic on OpenShift. So you can have like thousands of pods running during the night in OpenShift, and then during the day, really nothing. So you really have the elasticity based on OpenShift. Then you have the natively built redundant mesh topologies. Here, in our case, we didn't use the automation mesh in here because it's still tech preview in AAP 2.3. But in future version, we will definitely use that. It will bring VMs connected to our AAP on OpenShift. And we can do so much more with execution nodes and hop nodes. Everything like that can be managed centrally with automation controller on OpenShift. And now let's talk more about the installation, how it's actually being installed on OpenShift. And for that, I would like to hand over back to Philippe, who will talk more about operator basics.
Exactly, and that's quite important to mention or to introduce first. So when we have OpenShift, there's a thing in it called operator. An operator is a piece of software which automates your tasks at the end. So that's a basic. In this schema, we saw like the OpenShift cluster. Then we have an important thing like the etcd and API. We only focus now on the etcd. It's the key value store where all the information of OpenShift are stored. And it's important since the operator, in this example, the Ansible Automation Platform operator, constantly watches these events. So whenever something changes in etcd, this operator, via reconciliation loops, recognizes that and will adjust your settings on the cluster. But how can actually a customer interact with this operator? So there are a term or resources called custom resources. The customer can create a custom resource to interact with an operator. As soon as now a customer or a user requests a new automation controller, he can upload the custom resource to etcd, and this operator realizes that and bootstraps your automation controller as well as the Postgre database in your namespace. So with this schema, we covered like the installation of a new AAP or automation controller instance. But these are many more functionalities or features the AAP provides. And therefore, I would like to hand over back to Silva so that he can give you a brief explanation what functionalities the basic operator brings with it and where it's the point that we had to enhance it.
Thank you, Philippe. So let's talk about operators and why we have the word cooperation. We used to have, in 2020 already, a Tower operator built for our Ansible Tower as a service on OpenShift 3. And when OpenShift 4 came, we had as well this Ansible Automation Platform operator, and we needed to have kind of the same features as we used to have, but on OpenShift 4. So we basically created another operator side by side with the one shipped by Red Hat, and they bring different features. As Philippe mentioned, we have our users. They want to have like AAP as a service, so they can actually order that, and this is via the creation of their custom resources within their customer namespace. And basically, we have different operators. Let's dive into the AAP one. What can you do? So a user can create a YAML file, and then he gets, there is a logic behind the operator, and you will be able to install your automation controller. You will be able as well to bootstrap immediately your LDAP configuration to handle RBAC. You can also do backup and restore. We covered that in day 2 operations. And then we have our own. What does it bring? What's the value of it? Why did we create it in the first place? Well, in the enterprise world, you want to have the users be ready to use this service within their corporation. And there is a lot of, let's say, integration that you want, and you don't want everybody to do that by themselves, but having this automated. We'll go through all the features that we have. So we are injecting directly the subscriptions, otherwise they are stuck at the login page where they need to inject a license. Second of all, we want to have this more corporate, to have this with a custom UI, and a lot of default settings so that they can really start using their playbooks within the company. So now let's really deep dive into this operator that we have created and how we did that. So in terms of cooperation, because this is important not to have the operators collide with each other, what we have done is this 6 AAP operator comes later in the game. So it will make sure like the first one gets created, and then we make sure that the automation controller is ready to be used so that we can inject our configuration. We do that with the use of Ansible as well. We are using the Kubernetes core collection to actually fetch some information about the cluster. We are using it to create our different objects, like secrets. We can also execute some commands to the pod to call some APIs. Regarding secret management, we are using a tool called HashiCorp Vault. So we are also using some other collections and roles to interact with some third-party secret management. And Ansible is really good at that. It can connect to any system. So it was really nice to have that. So let's talk more about the customer perspective. How do they actually create their automation controller? So the quality is not so good here. It's a bit weird, but let's continue. So this is basically the customer namespace. They have some pods. One is the Postgre, which is the database of automation controller. And the second one is the deployment of the automation controller. Please note that the Postgre pod is simply one container, but the automation controller is quite big. So you have like 4 containers with different use cases. You have Redis for handling the raw event, the task for more the scheduled capabilities, the web for everything UI related as well as API, and the EE for the Ansible receptor. And all of these containers can be tuned in terms of resources, because on OpenShift you are sharing maybe some resources, and you want to make sure like they have some limits and some requests to run that. So you have the different capability to say, hey, I want 3 replicas for my automation controller on different nodes. I want to have the task with more resources and so on to do their job. So you have this granularity. Then how do you actually handle advanced scheduling? You can actually have this node selector and to specify on which nodes you want to schedule them. Because maybe you have a big OpenShift cluster, but only some nodes are authorized to run AAP. So you can do this. Then, yes, to schedule the automation pods on specific nodes. Then we have the topology spread constraints. So this is actually to spread the pods in different nodes, because by default, Kubernetes will tell you, oh, this node is not being used, so it will basically put all the pods on one node. But you want to make sure like your automation controller are spread across the nodes, so that in case of a failure of a node, not all your automation pods are down. Last but not least, you can use taints and tolerations to have dedicated nodes, so that you really have your nodes on dedicated machines. So that's how you can do it. If you want to know more about the capabilities of this YAML file, you can find the reference architecture. It talks about how you can mount volumes. It talks about other aspects like extra settings and so on. There is a lot of documentation now. It was released in end of Q1, and it can really help you. Now let's go back to the 6 AAP operator, because what we talked about was really the one from Red Hat. So how do we handle the 6 AAP operator? So we have extended the Kubernetes API by creating this kind of object. And basically, we can inject some of the features. And this is basically the YAML that the user needs to create. So they simply need to create 2 YAML files, and then within 10 minutes, they will get everything ready for them. One part is, OK, how do I know that it will configure my automation controller? So it cannot be just random names. It needs to fit the name of the previously created automation controller, in that case, AAP showcase. And then you will have everything. So in a nutshell, the user simply needs to create these 2 YAML files. One we covered. The YAML can have like hundreds of lines because of all the settings you want to have. And then you simply need to create the second one like that. What it will do, it will create automatically your automation controller within your namespace, having all the features in there ready to be used by the enterprise. One of the things I was mentioning was the default settings. So for example, this part here is just not, we are not simply doing one setting. We are doing a multitude of settings, including external logging, so that every playbook that the user will launch will be audited and sent to Splunk for audit purposes, including authentication. Want to know in case of an audit what happened. But there are other things like monitoring. We'll go through that, how we can actually automate that. So having said that, maybe you are interested to know how we developed this 6 AAP operator and how it was achieved from the build side, but also from the deployment side. Because we are not simply doing that on one cluster. We are doing that on different clusters across Switzerland and Spain. And we want to have a consistency and a nice pipeline. So let's talk about continuous integration. Let's talk about Git. We have our source code in Git as an automation developer, and I want to actually build the image, because basically an operator is a container image, and we want to actually test this out on OpenShift automatically. And in case of a success, we can commit and push a specific release. This is also be done with Tecton. So everything within OpenShift, because we want to really use the OpenShift capabilities. But first, let's talk about Molecule and how we developed the operator. So we didn't reinvent the wheel. We used the operator SDK. So operator SDK helps you to create like operators, either in Golang, Helm, Ansible, as well as in Java. There is another project for that. And in our case, since we want to propose this AAP as a service on OpenShift, we chose Ansible. Of course, we cannot just go and develop this without testing that. So according to the operator framework, the best way is to use Molecule. But how did we do that? What kind of scenario we wanted to test? Well, we wanted to test all of these custom resources that we saw, all the YAMLs, and we want to make sure like there are no regression whenever we are changing some code or whenever we are testing some Red Hat operators from release to release. So we want to make sure all these tests are good, basically. And within Molecule, the tests are called basically scenarios. So how do we do it on our case for our own operator? So first, the first step is the destroy. So we want to clean that out in case there are some leftovers. Second part is the linting. So we want to make sure like we are following the standards regarding the Ansible playbooks and roles within our operator. The third one is the creation of our operator or operators. So the one from Red Hat is already installed, and then we are testing, for example, our own operator. So we create it. It comes from a new build, new release, and then we create the operands. So that's basically these CRs here, the YAMLs that I was talking about, the automation controller, and the sixth one. And then the most important one is the verify. I was talking about the regressions. We want to make sure we can inject and so that the user can actually use the platform and not say, oh, it's not working anymore. Can you have a fix? No, we want to make sure that this is already covered here. And regardless of the state, if it's successful or not, we will make sure to destroy it again so that we have a clean state and move on for the promotion process.
That's quite cool, Silva. I mean, imagine you have like 2 release trains. You have like this upstream project of Red Hat, right, where they develop the AAP. And you can't influence that. I mean, they can bring features, they can remove features, of course, deprecation, things like that. But we also have our own operator. And at some point, you want to make sure that even if you have like this separate development processes, that at the end, the service you provide to your customer won't really break at the end, right? So that was really a cool thing we invented here. So could you please tell us how it looks like in OpenShift?
Sure. So we are leveraging, as I said, Tecton. And our pipeline looks like this. So this is basically the OpenShift UI. And you have a tab called Pipelines and Pipeline Runs. So we are building everything within OpenShift. And here we are cloning the repos. Here we are copying some Ansible config because we are fetching some collections from Private Automation Hub. We are building the image with Builder. And we are testing it with Molecule. And if this is green, basically everything worked. We have committed to Git, and we have a new release. So that's how it works. And this is really important because I'm pretty sure in the next month or so, when we have AAP 2.4, this will be red. So we can work on the code to see, OK, what happened? Regarding the deployment, we're also using OpenShift. And one of the tools that is really cool for deployment is Argo CD. It really helps us to know the state in Git, but also in OpenShift. So we can know the difference between what is in Git and what's on OpenShift. Because It can be on Git, but maybe I don't know what's happening on OpenShift. So you can really see the delta and say, okay, well, there is a delta, so I need to make sure I close that gap with Argo CD. So basically Argo CD is watching constantly Git, and then it knows as well the state in OpenShift. And we have a templating mechanism with Customize. So this is a templating for OpenShift, for Kubernetes. You can also have other things like Helm. In our case, we rely on Customize, which comes by default with the operators decay when you create the Ansible operator. And so we are deploying this on different clusters. As you can see, we are deploying not only the 6 operator, but the one from Red Hat as well. So everything from the code base in Switzerland, but also in Spain. So we talked about the CI/CD now, but now let's talk more about the date from day 2 to day 100. What are the challenges? What are we paying attention, especially on OpenShift? So we will talk about monitoring using Prometheus and Grafana. We will talk as well about backup and restore. How you do backup your automation controller? Can it be done with OpenShift? We will not talk about upgrades because we won't have enough time to cover this today. So let's continue with the monitoring workflow. I talked about some default settings. So one of them is by default. In our case, we want to make sure we are creating, in our case, this is our 6 operator, and we are actually creating an auditor user. An auditor user is basically a read-only user because we don't want to use something else. And it will help us to automatically scrape the automation controller metrics. So the ones, so that you can get some insights about the customer workload. So we want to know, okay, how many jobs are they running to have a global view on their activities. But it will be also helpful for them to know, okay, what's the correlation between my metrics from automation controller and the memory usage? Do they need to scale? So we are creating this auditor user. We are also creating a Kubernetes secret. And we are linking this via Prometheus service exporter. This helps us to scrape automatically every 2 minutes the automation controller metrics. And from that, we are leveraging the OpenShift user workload monitoring, which is fully supported by Red Hat. To visualize that, we are using Grafana, which you will see in a second. So for those who cannot see this, is basically per namespace, per service, and per pod. You can see the automation controller memory usage. You can also see the automation controller jobs. And let's talk more about the metrics. So this one is basically per container, their memory usage. So I told you before that the automation controller pod is not only 1 container, but 4. And it will change in the future. I'm pretty sure it will have like, I think they are planning to change to have different pods, one for web, one for task. But in our case, we want to know in this version, okay, how much memory are they all using? Because that's quite important to tune. So as you see here, you had like, you have different patterns, right? And it's highly correlated to the automation controller jobs. And this data right here was coming from the automation metrics automatically. And this one is built in OpenShift. So we have combined everything in a single dashboard to correlate their resource management, to see what they are using, if they need to increase. Imagine you want to increase the number of jobs, the running ones, the pending ones, but you see here it's quite capped. So that's quite important for us to provide this kind of dashboard to the customer so they know, okay, do they need to increase resources to satisfy their playbooks. Having said that, let's move on to the backup and restore, and Philippe will take over.
Thank you much, Silva. Besides monitoring, also quite important topic is the backup. As we really love YAML files, as you saw in our presentation already, you can also use the custom resource called Automation Controller Backup. It's not so well documented, but you can find it actually in the upstream documentation from AAP. You can use it to create backups. It's quite easy. Name it, of course, since at some point you want to restore it, and then you need the name, obviously. And you need to define somewhere where it should store the backup. Currently supported is either PVCs, or if you want to have it more dynamically, you can also use a storage class for it. Unfortunately, S3 buckets, etc., are just not supported. But what's about, having a backup is great, but having a successful restore is even better. So when doing a restore, you can easily reference to the name we defined before. And another important thing we just saw during our tests, whenever you name the same deployment name, then several additional steps are required. You can find it in this article. I will also share these slides afterwards, so you have it all together. Depending on the restore, it could take a while. You could also face errors. Therefore, checking the status is always a good thing to go on to check what's going on with the restore. And this backup restore is nothing we invented, so it's really the basic functionality of AAP. With that said, I would like to pass over to Silva to explain what's really about this execution environment and why they are so cool.
Thank you, Philippe. So let's talk about this execution environment. What are they? So they are basically container images. They are built on Red Hat Universal Base Images. It provides quite a nice base as Linux. But then when it comes to Ansible playbooks, you want to have like a container image that supports this. And it's all about the dependencies, collections, libraries, Ansible core. So collections, everything related to Ansible. The libraries, you can have like some Ansible collections, but they have some dependencies. It can be Python modules, it can be RPMs. So that's quite important. And then you have the version of choice for Ansible, so the version 2.9, 2.14, and so on. You bring that there, and then you create your automation execution environment. But how do we actually reuse that, and how do we scale? Comes into the next step. So we are talking also about migration, because in the previous version, we are using a Python virtual environment, and now we need to create a container image. So with which tool do we create that? We're actually using Ansible Builder heavily. So basically, you want to define in a file called, let's say, execution environment, and you define in there the different files for your dependencies. So let's say you want to have like your collections, you define a file with the correct format, and you say for the playbooks you want to use, oh, I want to use the community score collection, right? Then you have the Python, everything you need. So maybe the vendor says, hey, I want to use the Boto Python module, you put that in there. And then if you need like special Ansible core version, you can also have it. But the challenge here, especially for 6, was we are working in a disconnected environment. We don't want to fetch the things from Ansible Galaxy. We don't want to fetch the things from the internet. So what we have created was basically some a pipeline, and we are recreating the Ansible runner, we are recreating the Ansible builder and the EE, and we are putting all the links to this internet-based access. We are putting it via our different proxies. So if we are talking about Python modules, we are actually using like a Python-specific index within the corporation. Same thing for Ansible Galaxy. We are replacing it via the private automation hub from Red Hat, which has like certified content. You can trust it, and then you have some kind of allow list for specific collections that are curated and of good quality. So we created that for them. So they will not pull directly from Red Hat. They will pull from our base images, and then they can start using that. So what's the next step for them? So basically, we have two parts. One is the control plane. We discussed this previously. They just need to create two YAML files, right? One for automation controller, one for SIX. And then you have the execution planes. So whenever they have created their containers, a container image, they are going to create their container groups. And in there, they define the execution environments. And then they can actually create their playbooks. When it comes into playbooks, then we are talking about job templates. You can map job templates to playbooks, and then when you run them for your automation, it can be a remediation, for example, it will create different pods. So these are what I was saying at the beginning in AAP2. They will appear in OpenShift, but in separated pods. They will not be collocated in that control plane. So that's the view on OpenShift. So now let's talk about the migration, how we helped the customers to migrate from Ansible Tower to AAP2, and Philippe will talk about that.
Thank you very much. So we heard in the last minutes how we build all these cool new tools, but at the end, without customers, I mean, it's useless, right? So how can actually customers migrate from either the old Tower environment, or I mean, if they weren't customers yet, how they can use it? It's actually like a three-step approach. So first of all, they need to have a project in OpenShift, as well as they need to create the AC, the automation controller custom resources. These two things are just like two YAML files which can be stored in Git. If it's got bootstrapped, the next step is do the migration from Python environment to execution environment. If you have it as well, you can already start executing your first job, but it's not done yet. So we provided the monitoring dashboard as well as all the observability for the customers, since fine-tuning is always a thing. So you can run it, but if you have like 400 concurrent jobs, you may hit resource constraints. So this is like an iteration which could take a while, but until here, it's like 10 minutes of work. Depends a bit on the execution environment, to be honest. But what customer use cases we actually have? I mean, you may ask yourself, do I need something similar for my environment? And we actually have three main cases. So one of our biggest customer, I would say, is our internal Linux team. So they use the Ansible Tower, this new Ansible Tower approach, quite extensively. So they are having like 400 concurrent jobs to automate and to ensure the integrity of the whole Linux environment. But it's not only bound to Linux. We also use this approach to manage all our OpenShift clusters simultaneously from one central place. It doesn't really matter where it's located, whether it's in Spain or in Switzerland or whatever. It's really one cool functionality we could use. And last but not least, we have many applications, maybe also smaller applications, which use this AAP as a service approach. So imagine you have like a service, like for example, in a shop, an e-commerce shop, when all the codes, all deployment stuff is in Git. You can just use the same Git repository, the same deployment methods you already had, and just use another CR to bootstrap then the whole automation stack for you as well. With that said, I would like to move to our reference page, since, I mean, now you may consider to also use, or to also create such an environment for you. And these are not just random links here, and I haven't just put this blog post because, well, we want to have a full list. But this is actually quite a good blog post. Kudos to Sylvain. It's written by him. And you also have some code snippets there. So if you haven't had the chance to take all the screenshots, or if you want to have some more detailed things, here you can get them. But, I mean, I also know that how it is if you don't really have the capacity to do that, or I mean, if you don't really want to do it by yourself, go through the references. You can also ask Red Hat Consulting. It's a product from Red Hat. They also have a booth in the Expedition Hall, and they are happy to help you achieving your goals. So with that said, I would like to give the floor to you. So if you have any question you may have, feel free to ask them.
So the question was regarding the data from Ansible Tower to AAP. Good question. So all our customers are using GitOps approach, so they have everything within Git regarding their configuration. When they migrated, they knew they were not going to keep the data. So whenever they started, everything regarding the data, like really historical data, was not kept. So they bootstrap their AAP instance, then they go over their configuration, creating all the job templates, everything like that. So they had everything in Git. So that's how it works.
So how do you get the credentials?
Yes, so you can use Ansible Vault to keep your credentials, and then they just had to recreate them. Yes. So the question, so that everybody hears that, it was regarding the configuration export. Let's say, like you configure this in Tower. Is it the same in AAP? Most of it, yes, but then you have these execution environments that comes on top, right? So all the new features from AAP, you need to consider this, because you cannot rely just on, for example, virtual Python environment. You'd rely on the execution environment in that case.
All right. And maybe we can take that offline afterwards. Any other things you want to bring up? If not, I would like to thank you guys for your time. As you may know, Switzerland is not only, well known for innovation, things like that, but also for chocolates. And not only the Swiss railway company can give chocolates, but also we have some chocolates. So if you'll leave it, you have like our colleagues from my team there. So grab your chocolates there and enjoy the rest of the stay.
Thank you.